Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. In this video lecture we are learning the concept effect of division by T property of the Laplace transformation. First let me write the property of this effect of division by T. This property says that Laplace transformation of f of t upon t. So this Laplace transformation is equal to integration s to infinity into phi of s ds, or some people may write this as integration s to infinity. So meaning of phi of s is Laplace transformation of f of t then ds. So where this phi of s is written as phi of s is equal to, this is Laplace transformation of f of t. So this property is called as effect of division by t property. So how to know that this property is called as effect of division by t? So whenever such type of 1 upon d term is present in the denominator, then this property is called as effect of division by t property. So now first find out integration for the limit s to infinity phi of s ds. Or phi of s, we may write this as Laplace transformation of f of t. So this is the value of f of t, numerator value, so take its Laplace transformation. So where the value of phi of s is Laplace transformation of f of t. So this is called as effect of division by t property. So now to understand this property, take the example. So example is evaluate. So first example is evaluate. Suppose this is e raised to minus at minus e raised to minus bt upon t. So find out its Laplace transformation. So evaluate this term. So in question paper, question may be of the type, or find Laplace transform of e raised to minus at minus e raised to minus bt upon t. So question may be of this form or maybe of this form. Now to find out the Laplace transformation of this term, we are using effect of division by t property, because 1 upon single t term is present in the denominator. Whenever such type of term is present in the denominator, use this property. So now according to this effect of division by t property, we write this as Laplace transformation of e raised to minus at minus e raised to minus bt upon t is equal to. So this is about this function. Now value of f of t is e raised to minus at minus e raised to minus bt. So we can write its Laplace transformation as integration s to infinity into Laplace transformation of f of t. So Laplace transformation of. So if we compare this, then the value of f of t is e raised to minus at minus e raised to minus bt into ds. So this is because of the effect of division by t property. Now according to the linearity property of the Laplace transformation, we can write this as Laplace transformation of e raised to minus at minus Laplace transformation of e raised to minus bt, so into ds. So this is the step because of the linearity property of the Laplace transformation. Now just find out the Laplace transformation of this function. We get this as integration s to infinity. So we know that Laplace transformation of e raised to minus at, so this is of the type e raised to minus at, which is 1 upon s plus a. So here value of a is itself, so we get this as 1 upon s plus a. Again this is minus, this is 1 upon s plus b. So here value of a is b, so into ds. Now this is the value because of the standard result of the Laplace transformation. Now find out the integration of this term as well as this term. So we get the integration of this term as, we know that integration of f dash of x upon f of x dx is equal to log of f of x. That means when numerator is the derivative of denominator, then integration is log of denominator. So derivative of s plus 1 with respect to s is 1, which is present in the numerator. So we can write the integration of this term as log of s plus a minus, this is again log of s plus b, and its limit is s to infinity. So whenever limit is s to infinity, so we can write this step in this way. So moreover, we can write this as log of s plus a upon s plus b. So power or limit for this term is s to infinity. Friends, when we put the value of upper limit as infinity, so when we put the value of upper limit as infinity, then we get this as log of infinity, and value of log of infinity is infinity. So we can adjust this term in such a way that we get this as log of, this is 1 plus a upon s divided by, this is 1 plus b upon s. So after taking s or dividing this by s, its limit is s to infinity. So its limit is s to infinity. Now if we put the value of upper limit, which is infinity, if we put s is equal to infinity, then this term become 1 upon infinity. So this is 1 upon infinity, which is 0. So this term is 0 when we put the value of upper limit. So again this term becomes 0 when we put the value of upper limit, and we get this as 1 upon 1. So finally we get the value of log of 1. Then this is minus, this is log of 1 plus a upon s divided by 1 plus b upon s. So after putting the value of lower limit, we get the second term as it is. So now if we simplify this term, then after simplifying this term, we get next step as, so again the value of log of 1, value of log of 1 is 0. We get this as 0 minus, this is log of, after rearranging this term, we get this as s plus a upon s divided by s plus b upon s. So denominator s term will get cancelled. So this is the next step. Now here minus sign, we can again simplify this as log of s plus a, and this is minus minus plus log of s plus b. So this is the term. So now this is plus term, this is minus term. So according to the logarithmic formula, so formula is, so log of a minus log of b is equal to log of a upon b formula. So according to this, we write this as log of s plus b upon s plus a. So in this way we can solve the example based on effect of division by t property. So this is the simple example. So this example asked many times in many examination of university and autonomous examination. So this is one of the simple example. Now to understand this concept clearly, take some more example for the practice. Now take some more example. So this is one of the simple example. So now next example is, so now next example is evaluate Laplace transformation of, suppose this is cos of at minus cos of bt upon t. Or in question paper, they may ask the question that find the Laplace transformation of cos of at minus cos of bt upon t. So here in denominator t term is present. So because of this t term, we apply the concept that is called as effect of division by t property. So according to this property, we can write this as Laplace transformation of cos of at minus cos of bt upon t is equal to. So we can write its Laplace transformation according to this property as integration s to infinity into Laplace transformation of cos of at minus cos of bt into ds. So this is because of the effect of division by t property. So now according to the linear property, we can write this as integration s to infinity Laplace transformation of cos of at first term minus Laplace transformation of cos of bt second term, then its integration with respect to s. So we can write this as integration s to infinity. Then we know the formula for Laplace transformation of cos of at, which is Laplace transformation of cos of at is s upon s square plus a square. So we write this as s upon s square plus a square, middle sign is minus. Again, same formula is applicable for this term, but value of a is b. So we can write this as s upon s square plus b square into integration with respect to s. Now find out the value of integration of this term. So now if we apply this formula, numerator is the derivative of denominator, then integration is log of denominator. So now here derivative of s square plus a square is 2s, and here we are getting only single s term, so we can multiply by 2 and we can divide by 2, so that numerator becomes the derivative of denominator. Similarly here, numerator is s, denominator is s square plus b square, derivative of denominator is 2s, so we can multiply and divide by 2, so that we can apply this formula. So after taking this step, this 1 upon 2 is common, so 1 upon 2 constant which is common, then this is log of s square plus a square minus this is log of s square plus b square, so its limit is s to infinity. So now after this step, next step is 1 upon 2 according to the logarithmic formula, log of a minus b, log of b, we can write this as log of s square plus a square upon s square plus b square with the limit s to infinity. So this is because of the formula log a minus log b is equal to log of a upon b. So put the value of upper limit, put the value of lower limit. But if we try to put the value of upper limit, then upper limit is infinity. We get this as log of infinity after putting s by infinity, and log of infinity is infinity. So to avoid infinity term, so adjust the denominator term in this way. So this is 1 upon 2, then log of this is 1 plus a square upon s square divided by 1 plus b square upon s square, its limit is s to infinity. So we adjust this term, so to avoid the log of infinity is equal to infinity term. So now if we put the value of upper limit, then this become 1 upon infinity. So then again 1 upon infinity is 0. So we get the value of this term is 0. So this value is 1. Again this value is 0. This is 1. So we get final answer as 1 upon 2. This is log of 1. 1 upon 1 is 1. So then minus, put the value of lower limit. Lower limit is s. So we can write this as log of 1 plus a square upon s square divided by 1 plus b square upon s square. So after putting the value of upper limit and lower limit, we get this step. So we may write, or we may simplify this as log of, again log of 1. So we know the value of log of 1. So log of 1 value is 0. So this first term is 0 minus this is log of s square plus a square upon this is a square plus b square. So in this way we get the answer. So again we may rewrite this as 1 upon 2, then this is minus log of s square plus a square, then minus minus become plus, this is log of s square plus b square. Then once again if we simplify this, then we get this as 1 upon 2, this is a plus and this is minus sign, so we may write this as log of s square plus b square upon s square plus a square. So now after writing this, this is the final answer. Or one may apply the next concept as, so one may apply the concept that, so we know the formula n into log of x is equal to log of x raised to n. So if we apply this formula, then this power may get changed, power may get raised to 1/2. So then the equation may get changed. That means final answer you may get in different form. But we may put this answer up to this step. So in this way, we will solve the example based on the effect of division by property T. So this is the second example. Now let's take the third example for learning this property. Now next example is find Laplace transform of 1 upon t in bracket 1 minus, suppose this is cos of t. So to find out the Laplace transformation of this function, so we know that Laplace transformation of 1 upon t into 1 minus cos of t. So here in this equation or in this example, 1 upon t term is present. So according to the effect of division by t property, so we can write this as integration s to infinity into phi of s, meaning of phi of s is Laplace transformation of f of t, which is Laplace transformation of 1 minus this is cos of t into ds. So again we can simplify this as integration s to infinity Laplace transformation of 1 minus Laplace transformation of cos of t into ds. So this is because of the linearity property of the Laplace transformation. So once again, if we simplify this, then we get this as integration s to infinity, then Laplace transformation of 1, according to the standard result, Laplace transformation of 1 is 1 upon s. So we can write this as 1 upon s minus, so Laplace transformation of cos of t. So this result is applicable, cos of at, which is s upon s square plus a square. So we can write this as s upon s square plus a square, value of a is 1. So we can write this as 1 square as 1 into ds. So now next step is to find out the value of integration of this term. So if we try to find the integration of this term, then we get the integration of 1 upon s. So we know that integration of 1 upon s is log of s, because derivative of numerator is present in the derivative of denominator is present in the numerator. So we can write this as log of denominator. So derivative of s is 1, which is present in the numerator, but here derivative of this term is 2s. So here only s is present, so we can multiply and divide by 2. So we get this as minus 1 upon 2 into log of s square plus 1. So its limit is s to infinity. So if we take the term 1 upon minus 2 common, so then we get this as, so take the term minus 1 upon 2 common, then we get this term as, so after taking this 1 upon 2 common, so we multiply by this minus 2, then this is log of s, then this minus minus become plus, then this is log of s square plus 1, its limit is s to infinity. So once again, if we simplify this, then we get this as minus 1 upon 2, then this is log of s square plus 1 upon, so if we take this in power of s, then according to the theorem, n into log of x is equal to log of x raised to n. So this 2 goes to the power of s, and because of this minus sign, we get this as log of a minus log of b is equal to log of a upon b. So we can write this as log of a upon, so this is log of s, or this is log of s square plus 1 upon, this is s square. So now here its limit is s to infinity. So moreover, we can write this term as 1 upon 2 as it is, then this is log of this s square upon s square will get cancelled, so this is 1 upon 1 plus s square. So this is the term, and its limit is s to infinity. So its limit is s to infinity. So now if we put the value of upper limit, then we get this as So upper limit is infinity, so this become 1 upon infinity. So value of 1 upon infinity is 0, so this term is 0, so we get this answer as log of 1, this first term, minus, next is lower limit which is s. So after putting the value of lower limit, we get this as 1 upon 1 plus s square. So this is the lower limit of the given equation. So once again simplify this term, but before simplifying this term, so value of log of 1, so value of log of 1 is 0, so we can write this as 0. So this minus minus become plus, so this is 1 upon 2 into log of, if we readjust this term, then we get this as s square plus 1 upon s square. So in this way we will reach to the answer of the given question. So this is one of the simple question for learning the effect of division by t property. So this is the third example. Now let's take the fourth example for understanding this concept clearly. Now friend, let's take the next example. So next example is find the Laplace transformation of 1 upon t into sine of 2t minus sine of t. So now let's try to solve this example. So now here in denominator we get single t term, so we can apply effect of division by t property. So then Laplace transformation of 1 upon t, so in bracket this is sine of 2t minus sine of t is equal to. So according to this property, we can write this as integration s to infinity into Laplace transformation of sine of 2t minus this is sine of t into ds. So this is because of the effect of division by t property of the Laplace transformation. Moreover, we can write this as integration s to infinity Laplace transformation of sine of 2t, first term, middle sign is minus, again Laplace transformation of sine of t into ds. So this is because of the linearity property of the Laplace transformation. So moreover, we can write this as integration s to infinity Laplace transformation of sine of 2t. According to this formula, we can write this as 2 upon s square plus 4, then this is minus 1 upon this is s square plus 1 into ds. So this is because of the standard result of the Laplace transformation. Now find out the integration of first as well as second term. So we know that, so in the first integration this 2 is constant, we take outside the integration, then this is of the type 1 upon s square plus 4. So this equation is of the type integration 1 upon x square plus a square dx. Is this is equal to actually its answer is 1 upon a into tan inverse this is x by a. So this is the formula for the integration. If we apply this formula for the integration here, then we get this as, so a square, that means this is the value of 2 square, so we can write this as 1 upon 2 into this is tan inverse this is s by 2 minus, so here the value of a is 1, so we can write this as minus 1 upon 1, so into tan inverse s by 1. So now limit for this term is s to infinity. So this 2 will get cancelled. So now remaining term is tan inverse s by 2 minus tan inverse s, its limit is s to infinity. So we know that tan inverse infinity, so tan inverse infinity is pi by 2 minus this is pi by 2, so this is the value of upper limit, then minus value of lower limit, so value of lower limit is tan inverse s by 2 minus this is tan inverse s, this is the value of lower limit. So then this minus and plus will get cancelled, so finally we will reach to the answer, so minus tan inverse s by 2, then this is minus minus become plus, then this is tan inverse s, or for simplicity we can write this as tan inverse s minus tan inverse s by 2. So this is one of the simple example for solving or for learning the property which is called as effect of division by t property. Now take one more example. Now friends, take the next example. So next example is find the Laplace transform of, so we can take next example as 2 times sine of t into sine of 2t upon t. So this is the critical example. So we will solve this example so that you will get idea about solving the critical examples. So now here we can solve this example as find the Laplace transformation of this function. So now we can write this as Laplace transformation of 2 times sine t into sine of 2t upon t. So because of the 1 upon t term, so we can apply effect of division by t property because 1 upon t term is present here. So according to this property, we write this as integration s to infinity into Laplace transformation of f of t, where the value of f of t is 2 times sine t into sine of 2t into ds. But to find out the Laplace transformation of this function, so we cannot apply these 9 standard results for finding the Laplace transformation of this function. So we have to apply some trigonometric formula and convert this product of 2 sine term in terms of single terms of this Laplace transformation, or convert this in terms of single function so that we can apply the standard result. We know the result 2 times sine A sine B is equal to, this is cos of A minus B minus cos of A plus this. So this formula we already learned during our first lecture of Laplace transformation. That lecture we mentioned as basic results related to the Laplace transformation. So now if we apply this result, then we get this as 2 times sine of t sine of 2t is equal to cos of, this is t minus 2t, so we get this answer as minus t, and we know the value of cos of minus t, so value of cos of minus t is same as that of the value of cos of t. So now if we apply this concept, then we get this value as cos of t, then minus, so a plus b, that means this is the value of t plus 2t, so we get the value as 3t. So now this is cos of 3t. So now here we get single term, Now because of this formula, we can easily take the Laplace transformation of this single function. Now put this value in the Laplace transformation, we get next step as, which is equal to 1 upon integration s to infinity into Laplace transformation of cos of t minus cos of 3t into ds. So this is first term, this is second term, in between minus sign is there, so apply the linearity property of the Laplace transformation. So we can write this as integration s to infinity Laplace transformation of cos of t minus Laplace transformation of cos of 3t into ds. So this is because of the linearity property of the Laplace transformation. So which is equal to integration s to infinity, then Laplace transformation of cos of t. Laplace transformation of cos of t is s upon s square plus s square. Here the value of a is 1, so we can write this as s upon s square plus 1. Again middle sign is minus, so again next term is same, but value of a is 3, so we can write this as s upon s square plus 3 square, which is 9, so into ds. So now next step is to find out the integration of this term. So now to find out the integration of this term, so derivative of s square plus 1 is 2s, so we are applying the formula. So numerator is the derivative of denominator, then its integration is log of denominator. So then here derivative is 2s, so derivative of s square plus 1 is 2s, so we get here 2, so multiply and divide by 2, so again its derivative is 2, so we can write this as 2, so this 2 will get cancelled, so we write this as 1 upon 2, then log of s square plus 1 minus this is log of s square plus 9 into limit s to infinity. So again, according to the logarithmic formula, we can write this as log of s square plus 1 upon this is s square plus 9 and its limit is s to infinity. So if we try to put the value of upper limit, then we get the answer of this term as log of infinity. So we get this value as log of infinity if we put the value of upper limit. So we get answer as infinity. So to avoid the infinity term, so we can adjust this term as 1 upon 2, then this is log of 1 plus 1 upon s square divided by, so this is 1 plus 9 upon s square. So its limit is s to infinity. Now if we put the value of upper limit, then this become 1 upon infinity. So value of 1 upon infinity is 0. So this term is 0, this term is 0. So we get the next step as 1 upon 2, then log of 1, because 1 upon 1 is 1. So answer is log of 1 minus, so if we put the value of lower limit, then this become 1 plus 1 upon s square, so divided by 1 plus 9 upon s square. If we simplify this, then we know the value of log of 1. So value of log of 1 is 0. So according to this, we write this as 1 upon 2, 0 minus this is log of s square plus 1 divided by s square plus 9. So s square from both the denominator term will get cancelled. So now, so this can be written as 1 upon 2 log of a minus log of b. So according to this, we write this as s square plus 9 upon s square plus 1. So now here we solve near about 5 to 6 example based on effect of division by t property. Now let's take some example for your practice as a exercise. So now take the exercise. Now friends, time is to test your knowledge. So for testing your knowledge based on effect of division by t property, so total 6 examples are given for your practice. So solve all these 6 examples based on effect of division by t property. So clear your concepts. So for telling your answer, so answers of all the questions are provided here. So solve this all the examples. Friends, I hope you like these lectures. So thanks one and all.